Ever wondered how machine learning works? It's not as complicated as you might think. Imagine machine learning as a journey that begins with a single step: data collection. Data is the lifeblood of machine learning, feeding our models with the knowledge they need to make accurate predictions. This data can come from a myriad of sources, whether it's databases, text files, or even images and audio files. But it's not just about gathering a mountain of data. The quality and relevance of this data play a crucial role in determining the performance of our machine learning model. So we don't just collect data, we curate it, ensuring it's in a format our models can understand, and that it's relevant to the problem we're trying to solve. So the first step in the journey of machine learning is data collection. But what happens after we have the data? Now that we've collected the data, it's time to make sense of it. This is where data pre-processing comes into play. Picture this. You're hosting a dinner party, and you've just brought home a bag of fresh ingredients. Before you can start cooking, you need to prep. You clean the vegetables, trim the meat, and measure out the spices. That's pretty much what data pre-processing is in the world of machine learning. It involves cleaning the data, removing any duplicates, and correcting errors. It also means handling missing data, either by removing it or filling it in. Lastly, it involves normalizing the data, scaling it to a standard format. This isn't a step to be glossed over. A thorough pre-processing can significantly improve the accuracy of your model. It's like using fresh, high-quality ingredients for your dinner party. It just makes the end result that much better. With our data all cleaned up and ready, it's time to choose the right model. Choosing the right model can be likened to choosing the right tool for a job. In the realm of machine learning, the task at hand is deciphering your data, and the tool, well, that's your model. With a plethora of models to choose from like linear regression, decision trees, or neural networks, your choice should hinge on the nature of your data, the complexity of the problem, and the computational resources at your disposal. Once you've picked your model, it's time to train. Imagine training as a sort of apprenticeship for your model. It's where your model learns the ropes, adjusting its internal parameters to better predict the output. But beware of overfitting, where your model becomes a know-it-all, excelling only on familiar data, but stumbling on anything new. And avoid underfitting, where your model struggles to make sense of both new and familiar data. Training is crucial, but how do we know if our model is performing well? That's where evaluation comes in. Evaluation is like the report card of our model. It tells us how well or poorly it's performed. Once we've trained our model, it's important to evaluate its performance using new data. Common metrics include accuracy for classification problems, precision and recall for binary classification, and mean squared error for regression problems. But what if the model isn't performing as expected? This is where hyperparameter tuning comes into play. It's like fine-tuning a musical instrument to get the best sound. We adjust the model's parameters to improve its performance, using techniques like grid search and cross-validation. Finally, once our model is trained and optimized, it's ready to make predictions on new data. This is like the moment of truth, where we see our model in action. Once we're satisfied with its performance, we deploy the model. It's integrated into a real-world environment, processing real data, delivering insights, and driving decisions. And there you have it. The journey of machine learning, from data collection to deployment. It's a fascinating process that's driving the future of technology.